Okay, guys, so we're going to, let's go ahead and close this out. Okay, so what I want you guys to do is finish off the numerical methods project. So you're going to have to write code for the bisection method, the Newton's method, and the secant method. You guys wrote the code for the bisection method in class. I'm going to go ahead and live code both the bisection method and the Newton method for you guys. And I'm going to want you guys to finish off the secant method, go into the document on the lab, which is going to require you to do multiple equations. And I'll show you how to set that up as well. But the big thing here is I want to kind of show you how I would live code this, assuming that I had already sketched out the code for the bisection method. So let's go here. We're going to create a new project. New project, Java project. Let's call it Numerical Methods. No, we don't need a Java. Yeah, Java perspective. Great. Okay, so I have numerical methods. I need to add a class, new Java class. Let's call it numerical methods. I want to make sure we have an initial capital. Down here, I'm going to go ahead and have a public static void main because we're going to do all this we're going to do all this with a main. One class and one class only. Okay, so my code, I know I was going to need a class to do bisection. So let's call it public static void. Return anything. It actually does return something. So return the double, which is the actual x value where the root is. We'll call it bisection. We need to give it two things. We need to give it 1 point on one side of the x-axis and another point on the other side of the x-axis. I'm going to go ahead and keep my variable names very similar, if not exact, to what the page is. And so first thing we need to do is find a midpoint. We're going to call that C. And the way we do midpoint is A plus B. Make sure you put that in parentheses properly, otherwise it's not going to calculate correctly. And then you need a while loop. So while our absolute value of, we need a function, crap, which we call a function. Let's call the function f. So we'll call, while our function, let's go ahead and define our function. Public static double, because the function should probably return something. That's a double. Let's call it f. And all that's going to do is get a value for x, and we're going to return some y value, right? And we want to return, let's do x squared minus 5x minus 6. So first time out, let's put the comments out here. X squared minus 5x minus 6 will be our first equation. And let's use math.pow, just get used, even though we could do x star x. Let's do math.pow. That's great. Put it in there, and the first value is going to be x. What value are we going to raise it to? Let's raise it to a 2. And make sure I'm getting in the right parentheses. So this parentheses goes with this one. So I want to be outside of that one. Minus 5 star x minus 6. There we go. We need to put a little semicolon there. Hot dog. So now we have our F method. We can go ahead and give it a double, and the double is going to be, we need to calculate where C is, right? And if it's really close to 0, so we're going to need some kind of static final double. We don't want to be int. Let's just call it stop. Remember, constants should be all caps. And let's set that 2.00001. Awesome. Make that more zeros if we want to be more precise. So how many zeros is that? 1, 2, 3, 4, 5, 6 zeros. All right, so while the absolute value when I calculate it is, because remember when I calculate it, it could be a negative value or a positive value really close to 0. So it could be negative 0.000001 or a positive 0.000001. And while that's less than or greater than stop, while our value is greater than the stop value, we want to do this loop. And what's the loop we want to do? We want to do if f of c or f of a. All right, so if you multiply them together and it's greater than 0, which is the same thing as saying if they're on the same side of the x-axis. So I got my parentheses messed up here. F of c times f of a is greater than 0, so if they're on the same side of the x-axis, then I want to make a equal to c. I want to move a equal to c. Remember, you only have 2 scenarios. One is where C and A are on the same side, or one where C and B are on the same side. So if C and B are on the same side, we want to, I probably shouldn't, let's go ahead and do this. Put brackets in, even though there's one line of code, let's put brackets in because it's just good programming. That's good programming style, because if you need to add another line of code, which we may need to do, we're not going to, but which we may need to do, then you're all set up to add it in there. All right. And if, why is that not right? Why is that giving me a hard time here? Oh. How about that? Now we're better. Okay, so if that's, then we want to make, we want to make B equal to C. So if B and T are on the same side, then we want to make B equal to C, which will make B closer to the x-axis. And and then after we're done all that, then we have to recalculate a new C. So let's take this code up here. Take this code up here. And I'll paste it down here. Okay, so this, let's go ahead and do our states. That's with our else. This is with our while. So if we're done our while loop, right, we can go ahead, and that means we're really close to 0. We can go ahead and return C. C will be the value, basically our X value for the root. So we'll return C. Now, one thing we're also supposed to do is we're supposed to keep count. So let's do this. Let's create just a static binary count. And we're going to make it global. That way we can get it in the main. Let's set our binary count to 0. But we're going to be calling this more than once because we're going to have multiple equations. Set our binary count.